All right, welcome back. So now we're going to be looking at factoring. Factoring is kind of the reverse operation when it comes to expanding. So we did expansion, and sometimes that's really helpful because it helps us simplify after we expand, and sometimes factoring is very helpful. So when we've got something like 8a minus 12, the first method we're going to talk about is the highest common factor. Typically, we abbreviate this to HCF. And highest common factor is the largest factor that we can find in common between however many terms we have. So in this case, we've got two terms, and we're looking for the highest common factor between them. Now, one thing to consider is that sometimes we'll find a common factor that is both numerical, like our 12 and our 8, and we'll also find a common factor that has to do with our algebraic pronumeral. So in this one, because there's only one term that has a pronumeral, we don't have to consider them having a common factor that is going to be a pronumeral. So right now, let's think only about the numbers. And we would have done this a while ago, but when we're listing our common factors, one way to do it and one way to find the highest common factor is to list out all the multiples that make each one of these values. So for the coefficient 8, what are the multiples of 8? Well, we can do 1 times 8, 2 times 4, and that's about it. And then for 12, well, there's 1 times 12, there's 2 times 6, and there's 3 times 4. Now, once you've got these all written out, you can look for the ones that they have in common. The highest value that they have in common is actually a 4. So for this example, the highest common factor is going to be 4. Now, what does this mean for our factoring of this particular expression? Well, that means we're just going to rewrite the expression, but we're going to factor out a 4, which means we'll put the 4 out the front, and in brackets, we're going to divide each term by the highest common factor. Okay? What does this mean? So 8a divided by 4. Well, what's 8 groups of 8 groups of a divided by 4 groups of a, right, is going to give 2 groups of a. I'll make a quick change to that. It's going to give 2 groups of a. So this will be 4 times 2a, and then minus 12 divided by 4 is just 3. Okay, so this is another way of writing out this expression up here. And if you multiply this out, just like we did with the expanding, you could get back to our original expression. So 4 times 2a is 8a, and 4 times minus 3 is minus 12. And we're right back to where we started. And that's why this is useful and potentially valuable for when you're studying later on, is that sometimes if I can get rid of this, if I can make this and factor out a number, then I can ultimately simplify operations or remove this for other purposes. So it's quite useful, but we'll get to that later. Right, so our second one is we're going to factor 6y squared minus 8y. Okay, now we can see that we have a pronumeral in both of them. The pronumeral is the same. So when we do this, we're going to consider the highest common factor that is numerical and the highest common factor that is a pronumeral. Okay, so let's start out by listing our factors. So what are the multiples of 6 and 8? Well, we've got 1 times 6 and we've got 2 times 3. Yeah, and that's us done. And then for 8, it's 1 times 8 and it's 2 times 4. So the highest numerical common factor we have is this 2. But we can also factor out one pronumeral. So if we look at both terms, we have 6y squared, which is 6 times y times y, minus 8 times y. So a common factor that both of them have is in fact y. So we can also factor out a y out of this expression. So what this looks at like now is if we rewrite it, 6y squared minus 8y is equal to, we'll take our HCF, which is 2y, and we're going to divide each term by our latest HCF. And it's important to note that this whole step isn't something you have to write out. You can solve this in your head. You don't have to actually do the working for it. And the reason I'm doing it is because we've just started. So 6y divided by 2y, well, we get rid of both of the y's, and then 6 divided by 2 is just 3. Unfortunately, I forgot to write square there, so we get rid of one set of y, and we're left with 3y. And for this one, we get rid of both y's, and 8 divided by 2 is just going to be 4. Okay? Just to be clear, when I have something like y squared divided by y, imagine that's y to the 1, which it is. We can cancel that, and we can take 1 away from the power of the top or the numerator. Alright, so our end result, our factored result, is 2y bracket 3y minus 4, and if you multiplied that out, you would get this where we started. So if you want to check your answer, just do the multiplication again at the end. Alright, next one, we have 12m to the power of 3 plus 18m to the power of 2. Okay, so we can list both of our coefficients and find the highest common factor that they have in common. That's a numerical, but we can also look at our algebraic side as well. So with our pronumerals, we can see that we have m to the power of 3 and m to the power of 2. So m to the power of 2 times m will get m to the power of 3. So we know that they have a common multiple of m to the power of 2 as well. So what's our values here? Well, we have 1 times 12, 2 times 6, 3 times 4. We have 18, 1 times 18, 2 times 9, 3 times 6, and so on. So now let's look at what the highest common factor between them is, and it's going to be 6. Right, and as I was saying before, if we go 12m squared times m, that is the same as this. This is exactly the same as the expression at the top, so we can factor out this m squared as well. So our highest common factor between them is in fact 6m to the power of 2. So we just need to divide both terms by 6m to the power of 2. So 6m to the power of 2 times 12m to the power of 3 divided by 6m to the power of 2 plus 18m to the power of 2 divided by 6m to the power of 2. Okay, firstly, if we've got two groups of, or m to the power of 2 down the bottom, we can get rid of that, and we can take 2 away from this top pronumeral, which just leaves us with m to the power of 1, or n. 12 divided by 6, well, 6 goes into 12 twice, and we're left with 2m. For this term here, we've got m to the power of 2 on both the top and the bottom. They both cancel, which means that if you divide m to the power of 2 by m to the power of 2, you'll just get 1. So it becomes 18 times 1, which is just 18. And then 18 divided by 6, well, that goes into it 3 times. So in the end, we're left with 6m to the power of 2 times 2m plus 3. All right, let's move on to another one. We have 9a squared b minus 15ab to the power of 2. Right, so just off the top, we can see that they both have at least one. They have one a in them, right? We can't do a to the power of 2 because that's only in one of them. And they both are multiplied by b, so we are going to have the ability to put b as something we can factor out as well. We can't do b to the power of 2 because they both only have on one term it's b to the power of 1, and then the other term is b to the power of 2. Now let's look at our numerical highest common factor. Okay, so what are the common factors between 9 and 15? Well, first let's do 1 times 9 and 3 times 3. And then 15, we have 1 times 15, and we have 5 times 3. And our highest common factor between the two of them is going to be 3. That means we can just add the 3, and 3ab is going to be our highest common factor. So let's do that. Now let's change this whole expression to a factored expression. (3ab), and we're going to divide these out. And that's 15 ab to the power of 2 divided by 3a. Okay, first up, b divided by b will just cancel and be 1. B squared divided by a will just leave us with an a. 9 divided by 3 will leave us with a 3. So this will simplify down to 3a. And the second term, we can get rid of the b, we can get rid of the power of 2, we can get rid of both a's, and we're left with 15 divided by 3, which is just going to be 5. So we're left with 5b. Okay, so 3ab times 3a minus 5b is our final answer for this one. Right, so now we have a larger one. So we've got 14x to the power of 3, y to the power of 2, minus 21x to the power of 2, y to the power of 3, plus 7x to the power of 2, y to the power of 2. So we're going to try and find our highest common factor between all three terms. It's exactly the same idea as what we did before. We're going to try and find our numerical common factor and then our algebraic common factor. So we can see that we share some terms. Okay, we have x to the power of 3, x squared, and x squared. So the highest algebraic common factor we can have between these three is x squared. For y, we have y squared, y to the power of 3 and y to the power of 2, which means our highest common factor for y is also going to be y to the power of 2. Now, we have to look at our three numbers. We have 14, we have 21, and we have 7. Now, I'm pretty sure you can see a common factor between all of these, but we'll go over it. So it's 1 times 14, it's 2 times 7. 1 times 21, and 3 times 7, and 1 times 7. So the highest common factor between all of these is going to be 7, and we just add that to the top, and we're left with our highest common factor being 7x squared y squared. Now we need to divide each term by that in order to solve. So we can rewrite the entire expression as 7x squared y squared into 14x to the power of 3 y to the power of 2 divided by 7x to the power of 2 y to the power of 2 minus 21 x to the power of 2 y to the power of 3 all over 7 x to the power of 2 y to the power of 2 and plus 7x to the power of 2 y to the power of 2 divided by 7x to the 2 y to the power of 2. Okay, very simply, this here has the same numerator as the denominator, which means all of these will cancel. If I divide 7 by 7, I get 1. X squared divided by x squared is 1, and y squared divided by y squared is going to be 1. So this all simplifies down to 1. For our other terms, we can start at the front and we can go, well, y squared divided by y squared, well, that's just going to be 1. X cubed divided by x squared is going to just leave us with x to the power of 1 or x, and 14 divided by 7 is just going to be 2. Then for our middle term, we have y to the power of 3 divided by y to the power of 2, which will just get rid of everything and leave y to the power of 1. X to the power of 2 divided by x to the power of 2 both divide and become 1. 21 divided by 7 is just going to be 3. So we end up with 7x squared y squared 2x minus 3y plus 1. Okay, that's it for this video. Hopefully it was helpful, and I will see you in the next one.